back on stage here at ContainerDays. Actually, see a few familiar faces from my Open Telemetry talk, so glad to have you here. And on this talk, I'd like to talk about cracking performance issues in microservices with distributed tracing. And let's start with the warm-up questions, with the raise of hands. Maybe someone can put it also on the platform. Who today is familiar with distributed tracing in the room? Round of, don't shy. Okay. Leave your hands up. Follow-up question. Who actually uses distributed tracing today? Leave your hands up only if you are also using it. Okay. Very nice. Cool. So the agenda for this talk is quite packed. I'm going to cover why you even need distributed tracing, what distributed tracing is about. I'll give some basic terms and concepts around it. And then I'll show you Jaeger open source project by the CNCF, the Cloud Native Computing Foundation. Then, if the demo gods help me, I will do some live demo of how you actually use Jaeger for investigating performance issues. Then I'll talk a bit about using Open Telemetry for instrumenting for distributed traces. And lastly, but very important, I'll give some common patterns to look for which can help you detect if you have performance issues in your system. So that's our plan for today. I'm Dotan Horovits. I'm the principal developer advocate at logs.io. At logs.io, we provide a SaaS platform for cloud-native observability that's based on popular open source tools such as Jaeger, Prometheus, OpenSearch, Elasticsearch, and so on. I'm an advocate of open source and communities in general, and the CNCF in particular. I co-organize the local CNCF chapter in Tel Aviv, so if you're around, do join one of our meetups. I also have a podcast, Open Observability Talks. So if you are interested in this topic, do check the podcast out. And in general, you can find me everywhere at Horovits. So why do we even need distributed tracing? In the, let's say, pre-microservice era, the monolith era is sometimes called, we used metrics to detect that something happened in our system. And then we went on and root caused the issue by looking at the logs, maybe putting breakpoints in the code and stepping through the code, maybe looking at the stack trace. That was pretty simple. But with microservices, when a single request involves maybe even hundreds or more services to satisfy it, when something breaks, or in the service, or when on the endpoint in the request, or maybe if the request is suddenly very long, have a high latency, how do we root cause and see where exactly that error or that performance degradation is coming from? That's a type of challenge, and obviously things that we used to do, like doing breakpoints in the code is not really relevant. We can run all the microservice stack on a local machine. We can't look at the stack traces really. And looking at the logs, actually it's not one log, right? We have thousands or more services, and each service serving maybe thousands or more requests per second. So if I want to investigate that specific problematic request, finding the log entries that actually match that specific transaction is very challenging. And as your application grows, it's becoming practically impossible to track the execution flow. And this is a diagram from the Uber, actually part of the system diagram of Uber. Just imagine tracing one individual trace throughout this monster. So that's what distributed tracing comes to solve. Distributed tracing, as you can see the definition, it's a method for profiling and monitoring our distributed system, our microservice architecture. And the most important part is the highlighted one. It helps pinpoint where failures occur and what causes poor performance. So again, a request comes into my system, and the endpoint suddenly gets back with an error, 404 or something else. Where exactly is that coming from within the, I don't know, hundreds or more services involved? Or if suddenly it takes a long time for the login to do, where exactly is this performance issue coming from? That's, in a nutshell, Distributed tracing has been around for slightly over a decade. Many attributed the current day distributed tracing to Google. Google developed their own in-house tool called DAPA. Though they haven't released it as open source, they did release a research paper around that back in 2010. That is a monumental research paper that really influenced what we know today as distributed tracing. So that's tracing in a nutshell. And as I told you, it is picking up very rapidly. This is from DevOps Pulse survey 2022. It's a yearly survey we run on the state of DevOps at Logs.io. And when we ask people which tools they use for observability, you see that 47% actually use distributed tracing. That's nearly half of the people doing something with distributed tracing. And actually, it's been growing steadily throughout the last 3 years. 2019, it was 19%, then year after 26%, now seeing 47%. So it's really picking up. And amongst those who don't yet use distributed tracing, 70% said that they're going to use that or adopt that in the coming 1 or 2 years. So it's really, tracing differently stands out as a central tool for monitoring distributed systems and microservices in particular. So I hope that I convinced you that it's interesting and you at least want to look into that. And with that, I'd like to go over some basic terms and concepts around distributed tracing. The most basic term, of course, is the trace. The trace is sort of the sequence of activities or operations that make up the request execution flow. You can think about it as a acyclic graph, like you see here on the left-hand side, of the different operations that were invoked. Each circle in this graph is a span. A span is one operation, a single operation within the trace of a specific microservice. The span has its name, the service name, the operation name. It has the start time, the duration of the span, how much time it took to execute, and additional information, tags. It can have contextualized logs and more things on it as a baggage. Where the A here on the graph is the root span, the one that actually received the original request that started this trace. And as I mentioned, there is something called context that flows through the trace, and each span carries it on and moves it over to the next span over thread boundaries, process boundaries, service boundaries. Context is very important. It typically contains the trace ID. That's the most important thing, a unified global ID for identifying the trace, but also a lot of other context that can be provided. By the way, some of that context you can set yourselves. So you determine the instrumentation, and based on what kinds of information you expose, you can just put it as baggage on top of the trace context. So it's very, very powerful, and it's very important to understand context is critical in distributed tracing, actually much more so than other types of telemetry like logs and metrics, because of that continuity that the trace makes up. So it's very important to be familiar. The power of distributed tracing lies on the context. And the context, as I mentioned, propagates through the system. Propagation is the mechanism of transferring it across boundaries. Typically, it's done over HTTP headers. There's a W3C standard for that. But luckily enough, you don't need to typically worry about that. It's taken care of for you by the instrumentation underneath the SDKs or whatever. So typically, you're not directly exposed to that. If I mention instrumentation, then instrumentation is essentially the process of making our code emit spans. Spans, you can think about spans like structured logs. So we need to get these structured logs out of the system, typically done with tracers or client libraries, SDKs that you use to instrument, and that take care of all of that context propagation that we talked about. And maybe the last term that I would like to mention in that context is sampling. For performance reasons, for efficiency reasons, we typically don't collect 100% of the traces, but rather a sample. And you can determine the sampling policy. For example, you can say, I want to collect only 0.1% of all the traces and store them and analyze them. So that's an example of a probabilistic policy. You can have rate limiting policy on others. There are different strategies, tail-based, head-based, and so on. I'm not going to go into all of these. My main takeaway for you from this is that the policy is your mechanism to balance between the efficiency and still keeping good observability into your system. So just for you to be aware of that. How does it look like from the system point of view? So we have our application, whichever programming language you use. It could be also polyglots or different languages. Each part of the application, each operation that is being executed emits this span, this structured log. You have like illustration here that logically shows you have the service name, the operation, the front end, the HTTP get /dispatch, timestamp, duration, and so on. And that is sent to an agent or a collector that collects all the spans, reconstructs the trace based on the causality, and sends it off to the backend for analytics, for analysis and visualization, and so on. That's how it fits. And in terms of the, and usually the visualization is this Gantt chart that you see here. We'll see that also on the demo, this timeline view that you can actually see for each span, not only how much it took, but also the relationship between them, which ran in parallel, which ran sequentially, and so on. The popular open source stack uses Open Telemetry for the application instrumentation and for the collector side, and Jaeger for the backend analytics. And I'll talk a bit more about Open Telemetry later on. Why Jaeger? Out of DevOps Pulse survey, you can see that Jaeger is definitely the leading choice for a tool for distributed tracing. 32% of those using distributed tracing use Jaeger. Interestingly enough, by the way, the second one is Zipkin, which is another open source. 15% use Zipkin. So nice to see open source taking a lead on distributed tracing. But definitely Jaeger is the most popular, which is what we're going to talk about now. Jaeger tracing, an open source by the Cloud Native Computing Foundation, but it actually started as a project inside Uber. Uber developed it as an in-house tool for their own needs in their scale, and then they contributed it, open sourced it and contributed to the CNCF in 2017. Then it reached graduation in the CNCF 2 years later. So it's been around already as a graduate project for a good few years, being used quite vastly as we saw. If you are interested in hearing more about the story of how Uber came to develop Jaeger and how they used it at their scale, I highly recommend you to check out the episode of Open Observability Talks that I hosted, a team member of Uber talking about how they did that. It's called Distributed Tracing at Uber Scale, so do check it out. It's a fascinating discussion I had with him, fireside chat. And with that, I want to go straight to the demo and show you distributed tracing in action, how the visualization works, how to investigate performance issues. I'll be using Logs.io's managed version of Jaeger for the demo, and I will use a demo app that's called Hot Rod. It's a mock ride-sharing app. Essentially, you see a simple JavaScript front end, button per customer. You click the button, and it calls the backend to find a car to come to that location, and it gives back the license plate and the estimated time of arrival. Pretty simple. But now the question is, the first question, how does a system look like? We're talking about microservice architecture. We want to see how it's architected. And rather than going to someone asking for a diagram of the system architecture, the nice thing about distributed tracing is that it can actually view the interactions between the services and build a live diagram of what actually is running in your environment and show a live diagram of that. So that's the first benefit, and let's start with that. I'm going to need to see how I'm switching over here, so apologies for that. Just a second. That's the part that is annoying, and wish me luck with the live demo here. Let's move to Mira. Okay. See? Okay, you can see that. That's a good start. So, this is Jaeger UI, as you can see. And let's move slightly here, zoom out. You can see the diagram. That's, again, a live diagram that is detected by Jaeger by just looking at the calls between services, the spans. And we can see a simple system, front end, then calling 3 other microservices, the driver service, the customer service, the route service, even 2 data stores, Redis and MySQL. Very easy, very plain. The numbers, by the way, are the numbers of the invocations of the calls. Plain and simple. Next up, let's look for individual traces on the search tab. Here we have the front-end service, because this is where the requests come in from. We saw that. I'm looking at all the operations for the last 2 hours. I filtered by minimum duration of 20 milliseconds just to look at the interesting ones, the ones that take slightly longer and maybe problematic. And then we can see here the circles that you see here at the top. Each circle is a trace. The bigger the circle, the meaning is that it has more spans involved in executing it. And more interestingly, the y-axis is the duration. So the higher up the graph, it means that the latency is higher, the duration is longer. So it's very easy to immediately see which ones are maybe taking longer and you want to start investigating. We can also compare very easily 2 different traces. For example, these 2 traces are the same service and operation, front end, HTTP get/dispatch. By the way, we can see the information of the trace. We see 50 spans, 2 errors. We see which spans are involved. We see that it took 1.84 seconds to run, which is maybe long, and we want to investigate. And then I can also compare 2 ones that are supposedly the same service and operation, but one has 50 spans, one has 51. Maybe I want to see what's the difference. Why is that different? And I can see a visual representation of the call flow, and I can see that here driver calls Redis, but here another one that has an extra call to Redis that attributes to an 8% more of the latency. So very easy way to diff, to compare 2 traces, sorry. And if we go into one of these traces, we can look at the timeline view. This is where most of the people spend most of their time. By the way, whether Jaeger or other tools, that's the conventional way, the Gantt chart, to understand the flow of the trace. Let's look, for example, here on the left-hand side, this indented list, and it's very easy to understand the story. We see front-end receiving the HTTP get/dispatch, the request for the car, calling customer, get customer, that has some MySQL call, then front-end calls driver for find nearest, a sequence of calls for Redis. By the way, we see the exclamation mark. That means that there are some errors, so we may want to look at it later. And then front-end calls route service for get route, a sequence of these calls. So it's very easy to understand the flow of the system. By the way, we can also look at it graphically. If I switch here to a graph view, again, very easy to see. Front-end calling driver, calling Redis, and so on. But I want to go back to the timeline view because this, again, is where most of the investigation is being made. And I want to look at how we can investigate using the distributed tracing tools. So on the right-hand side, each bar, again, each line is one span, and we can see a lot of information. If I expand here a span, I can see lots of information. For example, I can see here, let's see which tags. I can see HTTP get with code, HTTP status code 200. I can see the URL. I can see /dispatch with customer equals 392. So I already see an ID, customer ID that is being requested here, and more information. So it's pretty elaborate. And I can start my investigation. What's the immediate thing that pops to mind when you look at it? We see that, I don't know, maybe 70%, if not more of the time, the total time of the request is spent by the customer service, as you can see here, the get customer. And that is attributed to actually a MySQL call, a query on MySQL. So that's definitely something that I want to look into, especially since it's a critical path. So you can see that no other process or operation, can start before that ends. So if I want to optimize, that would be a good candidate, and I can open that span, look at the information. I can see here waiting for a lock behind 4 transactions, and then I see 1.18 seconds acquired lock. So out of a total time of 1.45 seconds, 1.18 seconds, we're waiting for a lock. So that's a good indication. We may want to do something about that. That's the way that you can use distributed tracing to investigate performance issues. Let's look at another example here quickly. We can see here, for example, that the driver find nearest operation makes a sequence of Redis calls, and you see that like staircase thing. That means essentially that we do these Redis calls sequentially. So we wait for one to end before we do the next one. And the total time here is 169 milliseconds. Maybe you want to look into running it in parallel, which will reduce it to, what's the longest here? 32 milliseconds. Imagine how much we can save by parallelizing this. What else we can see? We can see that these two are much longer than the rest, right? And if you see, these are exactly the ones with the error that we saw before, the exclamation mark. So maybe if we want to look at this error, maybe it will reduce also the total time. I can open that and look at the logs and can see here event Redis timeout in this case, which gives me a good indication of where I should start my root cause analysis. So that's very brief, I know, but I wanted to give you a sense of how distributed tracing is a hands-on tool for understanding first how your request flows and how to investigate performance issues in your system. Now I need to switch the magic again to the slide deck, so let's see how that will work. Okay. Okay, I see a slide, that's a good start. Now I'll make it into a slideshow. Here we go. I'll take my timer to the side. Sorry about the logistics here. It's easier when I have double screens at home. And now let's summarize what we've seen in the demo and then carry on. So, okay. So what we've seen. We've seen distributed transaction monitoring. We saw service dependency analysis, how it's easy to understand the architecture and the data flow of our application. We saw some performance and latency optimization points that we can do, some root cause analysis. We saw the distributed context propagation. Everything that we saw tagged along on the spans is context. Some of that was the HTTP code, return code, error code, and some of that was the SQL statement. All of that is types of context that you can put on the trace. And it enables us to zoom in on the details of individual operations. And one important tip, even if you deploy tracing, you probably still have logs out there in your system, and we want to combine the two. We want to actually correlate traces to logs so that we can do the root cause analysis. We can actually jump to the corresponding logs and carry on the investigation with that information. So the best practice is to take the trace ID and append it to all of your logs, log data, and then it's very easy. Once you start investigating, you can then go to your Kibana or whichever tool you use for log analytics and filter by the trace ID and look at the related logs. You can do that by copy-pasting, as I said, or some tools have it baked in. For example, at logs.io, you can click on the trace and say exploring Kibana, and it will immediately open the Kibana filtered out for that specific search criterion. But very, very important, don't keep the unified observability by correlating the signals. And now I would like to say a word about instrumentation with Open Telemetry. I know I see some faces here from my Open Telemetry talk, so don't worry, I'm not going to cover everything that I talked about. I'm going to specifically focus on distributed tracing and the integration with Jaeger. And let's start with a bit of history. Jaeger, originally, the open source project, covered all of the stack. So it provided traces, the client libraries, it provided a Jaeger agent, and it provided the backend, the query engine and UI and so on. And the client libraries were based on open tracing, open source specification. Then Open Tracing merged with another project, Open Census, to create Open Telemetry. And then Open Telemetry reached GA, general availability for traces, last year. And then, since then, Jaeger has been aligning with Open Telemetry, meaning that today you use Jaeger refers to Open Telemetry SDKs for instrumenting your application. It bases its agent on Open Telemetry collector, and it also supports, that's actually quite a recent announcement, that Jaeger supports OTLP, Open Telemetry Protocol. So you can ingest a native Open Telemetry trace data into Jaeger. So that's about that. And for those who haven't attended my talk, very briefly, Open Telemetry is a framework for generating and collecting telemetry data, not just traces, but also metrics and logs. So one platform for, one framework to rule them all, if you'd like. And also, it exports it to multiple destinations, not just to Jaeger. So you can send your metrics to Prometheus or other sources. So it's really a unified platform. And if you missed my talk, by the way, you're welcome to check out the recording of my talk from KubeCon in Valencia a few months ago. I have a lot of information there that I shared. And there's also a guide to Open Telemetry if you want to check out this guide that I wrote about Open Telemetry. Now, the remaining time, I would like to say a word about common patterns to look for when inspecting your traces in Jaeger or other tools that may indicate performance issues in your system. So pay attention. This can save you a lot of headaches in your investigations. The first one, we actually saw an example of that in the demo. That's the staircase pattern that indicates some serial calls. Sequential calls, you may want to check if you can parallelize it. Maybe you do bulk operations. Maybe if it's a database querying, you can do some joins to reduce the overall latency. It can be code changes, but sometimes it's even a parameter change in your thread pool or something like that, configuration change. So staircase, another example is the gap between spans that can indicate some slow inter-service communications, but it can also be an indication of a missing instrumentation. For example, you're running a query on a database, but the database driver doesn't have an instrumentation, so you may want to add that to get more visibility into that. Another pattern is spans finishing at the same time. That may indicate some connectivity issue that causing timeouts or errors, or maybe many threads waiting on the same lock or something like that. So this is where you'd like to go and say, why have we reached that timeout? Maybe we need to change the timeout configuration. Maybe we need to understand why we reach this locking combination. And by the way, this is also a good opportunity to enhance your instrumentation also in this part. So if you see that it's a locking around database, you can also add instrumentation there to get more visibility into that. And the last pattern I'd like to share is span spikes, long spikes, long spans, long-running spans, especially ones that have a lot of variance between different executions that may indicate slow queries or maybe caching issues that you may want to look at that. And in general, as I said before, if you have slow operations and you want to optimize them, look for the longest running spans and start your efforts there, because it's quite time-consuming to optimize latency. So start there where you'll get the overall impact, the biggest overall impact on your total request. So that's a good indication. One quick word about what's next in distributed tracing. So what I've shown you so far, that's the classic distributed tracing. But what we've added, and I'm glad to say that my colleagues at Logs.io contributed much of that into Jaeger project, open source project, is to go one level up, more into like APM type of activity. So I understand how to investigate a specific distributed trace. We saw that. But how do I know which trace to check? And for that, I would like to see some trends over my different spans. I would like to see the spike in my error rate, in my request rate, in my latency rate, and then click on an example trace from that and then start investigating. So that's something that we've added to Open Telemetry, actually, not for Jaeger. while the spans are being ingested into Open Telemetry collector, in addition to building out the trace and sending it over to a Jaeger backend or at any other backend, it also calculates the metrics from the span data. Remember, each span has its own duration and the request data and everything, so it can calculate the aggregated metrics and then exposes them as a Prometheus metrics, and then Jaeger backend has an endpoint to pull that and to query that metric data and then visualize it in this view that you see here. And then you can look at that and see the average latency, the request rate, the error rate, and so on, and then see where you have spikes, and then go and drill down. So it's like an APM, or we call it service performance monitoring type of experience, added to the Jaeger open source. So check it out. And with that, I'd like to summarize what we've seen. We've seen that how to investigate microservices. Sorry, that jumped on my screen. Apologies about that. We've seen that how to investigate microservice architecture. That's not trivial at all, definitely. And that distributed tracing is an essential tool, and many people already started adopting. We've seen it also here at the audience. The recommendation is to instrument your application using Open Telemetry. It has SDKs that you can instrument per language, and that keeps you future-proof and vendor-agnostic. And then use Jaeger to analyze, as an analysis backend, to analyze your performance. We saw some common patterns of what we'd be looking for in the timeline view to see. Use the trace ID. I remind you again, the trace ID also with your logs so that you can correlate trace log data. And as you've seen, open source is definitely future-proofing and standardizing this topic, so check it out, the stack. And I put some references, so if you want to take a screenshot of that, lots of references. I'm not going to go over that. The Jaeger obviously has a Slack channel on the CNCF. It has lots of other channels that you can see here. And of course, you're more than welcome to check out, I gave you a short link to Logs.io's tracing service that will have for free community edition. So with that, I would like to say thank you very much for listening, and glad to take some questions.
Thank you so much for this talk, Dotan. We have quite a few questions on Slido, so if you can.
Yeah, certainly. So what do you think of Grafana Tempo? Grafana Tempo, Grafana Lab has a suite of projects. So the most famous one, obviously, many know, is Grafana, which is the metric visualization, but they also released a newer Tempo, which is does much of the same. So it's also a distributed tracing tool or product. It's also open source, but it's AGPL, so it's a copyleft license. I don't know which one will determine if it's adequate for him or her. But again, you choose. Most of what you've seen is, it works the same way, the timeline view and everything, just a different choice of tools. What are the main, do I need to manually code tracing into my app and to handle the context propagation? So that's an excellent question. The context propagation usually is taken care of for you, so you use an SDK, a client library that takes care of the propagation for you. You can do that manually by, just like you do logs. You put a log in a code line that says send an error level code with this text message and so on. You can do that. You can also use auto-instrumentation agents that can help you extract logs, extract the spans without having to do code changes. So you can choose auto-instrumentation, manual instrumentation, or combination of both. What are the main differences between Jaeger and Datadog? Wow. So Datadog is much broader than just, they entered tracing. They haven't started from tracing. That's not their area of expertise, I guess, but they expanded like many other vendors that started, New Relic and Splunk and others, from one niche, metrics or logs or whatever, into a broad spectrum of observability. So Datadog offers today tracing. Obviously, it's not open source, so if that's something that matters to you, Jaeger is open source and it's under the foundation, but something to consider. Can Jaeger track requests outside Kubernetes, like WAF appliance? So Jaeger is not bound to Kubernetes, although they're both under the CNCF. Whichever spans that you send it it will then reconstruct. So as long as you take care of the context propagation, whether it's cloud native or other distributed systems, it can definitely work with that. Is there a way to correlate metrics with traces? So I talked about correlating traces to logs. You can also correlate metrics to traces. So if you have, I don't know, in Grafana, some dashboard, and you see something spiking, and you see, okay, I want to look at an example trace of that, there is something called exemplars that you can define that will link that, and that will, it's a baggage on the metric itself that can link to the trace ID of a sample trace that you can look into. Definitely very interesting and picks up in Prometheus project, in Open Telemetry project. Check out exemplars. We have time for more. What is the time lapse from the point of event occurring in the service to the traces collected and displayed? It's really dependent on the way that you process it, and also obviously network latency, what's the topology and where the backend sits with relation to where your system sits. And also for optimization reasons, some on the Open Telemetry collector do some sort of batching to optimize the network and so on. So it really depends on your configuration. So I can't really answer that in one note. What extra benefits Jaeger will provide after integration with Istio? So that's a good question, because we use not only our application, we also use some infrastructure components, right? We have Istio as a service mesh, if you know that. You can have some queue, I don't know, Kafka or something like that. And if they don't transfer and propagate the context is broken. And then you will not see it as one transaction. You'll see the transaction before Istio and then after Istio. So one of the, or Kafka or whichever. So it's very important when you work with frameworks to make sure that they handle the context propagation. There are lots of documentation on how to make sure of that. And definitely with service meshes, they have built-in capabilities, but you need to enable them and look into that. So Istio, in a nutshell, will help you instrument your overall, let's say, system flows. What are sensible sample policies for production traces? So sampling, for example, the default in Jaeger is 0.1% of the traces. Why does that make sense? I don't think it makes sense. I think I actually copied the number from the Google Dapper research paper, and since then people have been copy-pasting it. But you actually need to find the right balance in your sampling between how much load your system generates, how much visibility and granularity you need in your traces, and of course the cost of storing and analyzing that. So it really depends, and you need to sort of decide based on your topology and needs. We have time for more?
Yeah, we have two more.
Okay, so do you know any automated / AI tools for analyzing traces? I don't know of any tools designated for that. I know that some of the companies, for example, Logs.io, the company I work at, we run all sorts of algorithms to detect anomalies within the trace data. So it's usually part of your distributed tracing tool, but not I don't know, a separate tool that only does that. Definitely something that will be added, like it's been added to log analytics and metrics to find the needle in a haystack. But you'll find it in the tool of your choice, probably more than not. What about instrumentation of managed services such as databases from cloud providers? So they also expose trace data. Definitely look at the documentation. You need to look at the specific service that you're interested in, but definitely they also expose that. And usually, they, as I said, many of them aligned with Open Telemetry, so you can actually maybe even get that exposed as standard OTLP format traces, and then you can send it to Jaeger or to other distributed tracing systems. So cloud services should be part of your distributed tracing visibility, definitely. Is there a way to see trends across my traces, to detect problematic traces I should investigate? So that actually ties back to what I showed in very briefly at the end, the service performance monitoring. So if you see the error rate graph, or the latency, the duration rate, or the request rate, and you see suddenly a spike, something that is anomalous, then you can go drill down and look at the example traces for that. So the service performance monitoring in Jaeger does that, but other distributed tracing tools also have a similar capability. So it's like the APM-like experience for that. Okay. Can Jaeger trace across non-traditional request-response service boundaries, like service sends an event, which another process? The short answer is yes, for async flows as well. I gave the example before of Kafka, for example, as a messaging queue. So you need to make sure, and that's in the documentation of Kafka, how to enable the context propagation within Kafka. But other than that, definitely you need to take care of that. Otherwise, it will break your context. You will see that coming into Kafka, and then you'll see a separate trace going out. You won't be able to tie it to one single cohesive trace.
And that's it for the questions. Thank you so much for answering all those questions.
Thank you.
Thank you for your talk.